Hi, my name is Colin Sitzberger, and this is the PHYS 2212 Lab 1 charge tape. All right, the purpose of this experiment is to prepare pieces of charge clear tape, observe interactions, and then determine approximately how much excess charge is in one piece of clear tape. Our findings were that the charge of one piece of clear tape was 9.33 times 10 to the negative 9 newtons over coulombs, and there was one deficient electron for every 5.14 times 10 to the 6 atoms. Key concepts of this experiment were Coulomb's law, the law that states that forces placed on an object from an electric force is based on the Coulomb constant multiplied by the two charges and divided by the distance between the two charges squared. And then we were also using Newton's second law. And the model is based on the assumptions that we assume that each tape is the same charge and evenly distributed. We ignore all air resistance and treat each tape as a point charge. And the scenario here is that we hold both charged tapes together, measure the displacement of tape B as you bring the tape A closer to it, and then balance the force from the electric field with gravity to find the charge of the single piece of tape. And then here's the experiment. The procedure is that we will start by transferring electrons to another tape by sticking two pieces together and ripping one off. Then we'll hang a newly charged piece of tape from the ground with a side attached to two tall objects, and then create another piece of charged tape to hold it under the other charged tape and record the displacement of the hanging tape as the bottom tape approaches the top. All right, and here's the code. We drew out the free body diagram where the top is the top tape that is being displaced as the bottom tape approaches. And here you can see that we find that the tape has a charge of 9.3 times 10 to the negative 9, and that there's one electron for 5.14 times 10 to the 6 atoms. And any possible sources of error for this calculation or this experiment is that the electrons transferred through the fingers that could change the charge of either the tape. Similarly, electrons could have transferred from the surface of the tape that was attached to that could have changed the charge. And other forces other than gravity that affected the tape that were in the environment. All right, and then the conclusion, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? Nothing would change as long as the signs are still opposite, attraction still occurs, and vice versa. If the signs are still the same, the two forces will repel each other. And then why is it important to handle the charged tape as little as possible? Because touching a charged tape to another surface or through your hands could charge a transfer of electrons, which would cause the tape to lose its charge.